do it as a class. So everybody that's here will get credit for the quiz, and we'll just go through the problems together here. So we're going to start with number 1. You want to know how many liters of 20% alcohol solution should be added to 40 liters of 50% solution to make a 30% solution. So remember, the first thing we have to break down is what are the concentrations of the solutions that we are going to mix. So the two ingredients, or the two solutions we're mixing here, 20% and 50%. And then we're trying to achieve or create a 30% solution. Next, we talked about there's two things that are conserved. So two things that we can write equations about. One of them is total volume, or total weight, if that's what it's measured in. This one is measured in liters, so it's volume. The 40 liters goes with the 50%. We want to know how much of the 20%, so we're going to let that amount be X. And this does add up. This is conserved, means that they add up to make a total. So the amount of the 30% is X plus 40. The second thing that is conserved is the amount of solute. In this example, it's an alcohol solution. We're assuming it's an alcohol and water solution. So the alcohol would be the solute. So we're looking at the solute is always the active ingredient, what's being dissolved into the solution, or what the percent is describing in this case. So the total amount of solute is the concentration times the volume. So for the 20% solution, the concentration is 0.2 times the volume of X. We're going to add to that the amount of solute in the second solution. For the 50% solution, the amount of solute is the concentration of 0.5. Again, that's just the percent written as a decimal or rate, times that volume of 40. And that adds up to the total result for our 30% solution. That's a concentration of 0.3 times that volume of X plus 40. And now it's simply a matter of solving this equation. So our first step is going to be to combine whatever we can on either side. On the left side, there's nothing to do with the 0.2x. But we do have 0.5 plus or times 40 is going to be 20. Nothing more to combine on the left side. On the right side, we have 0.3 times x, which is 0.3x. 0.3 times 40, which is 12. So we've combined everything that we can combine on each side. The next step is to make sure the variable is on just one side. Right now it's on both sides. The smaller one is the 0.2x. It's positive, so we're going to get rid of it by subtracting. Remembering to subtract 0.2x from the other side as well. So our equation here is 20 equals 0.3x minus 0.2x is 0.1x plus 12. And now it's just a matter of solving the equation. Subtract 12. So 8 equals 0.1x. And we divide by 0.1. So 80 equals x. Now remember, once we've solved this equation, we're not necessarily done with the problem. We have to go back and make sure, first of all, to confirm what x actually represents. X was the volume of the 20% solution, which is 80. The units, my other volumes are in liters, so that will also be in liters. So that's what x represents. The second thing we need to make sure is make sure we've actually answered the question. And here the question is, how many liters of the 20% alcohol solution? And that's what the 80 is telling us. So that is our answer to that question, 80 liters. Second question. We want to make 100 milliliters of 5% alcohol solution. Mixing 2% and 7% solution. How much of each should be used? So again, we start off by looking at the concentrations, identifying what we're mixing, and what our desired result is in the problem. So here we are mixing 2% and 7% solutions. Now notice I'm not using an equal sign here, I'm using an arrow because 2 plus 7 does not equal 5, but our resulting solution is 5%. Next, we need to look at our total volumes. We do not know how much 2% or 7%, but we do know we want to have a total of 100 milliliters of the 5% solution. So now here's where we have to be a little creative naming our variables. I'm going to pick one of the solutions, either the 2% or the 7%, for the volume to be X. I'm going to pick the 7% just because in that case, given that choice, I usually pick the higher concentration solution, the higher percent, because it saves us from working with a bunch of negatives later. What that means is the amount of the 2% solution, remember these two amounts have to add up to this amount. If that's true, then working backwards is also true. This amount minus this amount has to give us this amount. So this is 100 minus X is the amount of that 2% solution. So then we look at the amount of solute. In this case, it would be alcohol, since it's an alcohol solution. And this is what actually gives us the equation that we can solve. Remember, it's concentration times amount. So for the 2%, it's 0.02 is the concentration. That's just the decimal form of the percent. Times the amount of 100 minus X. Plus, for the 7%, it's 0.07 times that amount of X equals, for our 5%, that's 0.05 times that amount of 100. So now we've created our equation. Let's combine what we can combine on either side. On the left side here, We have 0.02 times 100, which is 2. And 0.02 times negative x is negative 0.02x. Well, 0.07 times x is just 0.07x. Now, there's still more we can combine there. The 2 isn't going to change. But we've got a negative 0.02 and a positive 0.07 gives us a positive 0.05x. That's all we can combine on the left. Now we can go over to the right. 0.05 times 100 is 5. And now we're ready to solve this equation. Subtract 2 from both sides. 0.05x equals 3. And finally, we'll divide by the 0.05. X equals, I believe that's 60. Let me double check that. It is. Now again, we need to make sure we go back and confirm what X represents. Here, X was the amount of the 7% solution. So that's 60. My other amounts are in milliliters, so that's also in milliliters. Now we need to make sure we've answered the question. Well, the question was how much of each of those should be used. So we need both, not just the 7%, but also the 2%. So the 2% is 100 minus x, so that'll be 100 minus 60, or 40 milliliters. So our answer here is 40 milliliters, 2%, and 60 milliliters of the 7%. So our third question. How much sterling silver sterling silver is actually 92.5% silver. Sterling silver is named after, I can't remember the first name, but it was a guy named Stirling who actually discovered that if you alloy silver with copper, it drastically reduces the corrosion. Pure copper, I'm sure you've seen pennies, corrodes pretty bad over time. Pure silver actually corrodes way worse. But if you mix the two, that 7.5% copper in with the silver, it makes it so it does not corrode. It still will corrode some, but not nearly as bad as either one of them individually. And that percentage seems to be the optimal percentage to prevent corrosion and to maintain the appearance of a pure silver. So how much of that sterling silver, 92.5%, should be mixed with a 90% silver alloy to make 500 milligrams, actually 500 grams, not milligrams, of 91% silver alloy. Okay, so once again, we have to look at what we are mixing. We're mixing 92.5% and 90% in the hopes of creating 91%. Now here we're not looking at total volume, we're actually looking at total mass. So I'll just label it total amount. We have 500 grams, that's how much of that result we want. Yesterday we looked at several problems like the first one that we did today where we had a known amount of one of the ingredients and we want to know how much of the other one to mix with it. But in reality, most times what you know is what total amount you want to have. And you don't want to just randomly mix and have a bunch extra or run short. You want to shoot for that goal total. So again, I need to define X to be the amount of one of my other amounts or one of my other ingredients. I'm going to let it be, again, the higher concentration, the higher percent. That means the amount of the other one is going to be my total of 500 minus X. And then finally, of course, I'm looking at the amount of the solute. So 92.5% is a concentration of 0.925 times the amount of X plus 90% is a concentration of 0.9 times that amount of 500 minus X equals my desired result of 91% will be a concentration of 0.91 times an amount of 500. So again, my next step, this is the equation I'm going to solve, so it's to start combining. 0.925 times X is just 0.925X. Plus, we're going to distribute the 0.9. 0.9 times 500 is 450. 0.9 times negative X is a negative 0.9X. Well, there's more that we can combine over here. We can combine the 0.925X and the negative 0.9X to get 0.025X. And of course, the positive 450 is still there. And then on the right side, it's the 0.91 times 500, which is 455. Just confirming that. Now we're ready to just solve the equation. We'll subtract the 450, both sides. We get 0.025x equals 5. Now we can divide by 0.025. X equals 5 divided by 0.025, 200. Now, once again, we need to go back and make sure we know what X represents. X here represents the amount of the 92.5% or the sterling silver. The other amount's in grams, so that's also in grams. But we also need to make sure we've answered the question. We want to know how much of the sterling silver and how much of the 90%. So we have to answer the other half of the question. The 90% is 500 minus X. So that'd be 500 minus 200, which is 300 grams. So the technical answer here is 200 grams of the sterling silver, the 92.5%, and 300 grams of the 90% silver. Our fourth one was a slightly different approach. We're going to ask how many milliliters of pure water must be added to 100 milliliters of 30% saline solution to make 10% saline solution. So this one, when we are mixing here, we're mixing pure water, which is 0%, with a 30% saline solution. And we're trying to create a result of it's a 10% solution. And here we are given the total amount of the 30% solution is 100 milliliters. We're trying to find how much water, so we'll let X be the amount of water. So that adds up, the amount of the 10% solution will be X plus 100. So then our equation comes from the amount of solute. For the water, 0%, well, that's just 0 times X, which is going to be 0, by the way. We can forget about that. 30% is going to be 0.3 times that amount of 100 equals, on the right side, 10% will be 0.1 times that amount of X plus 100. And then we combine. So 0.3 times 100 is 30. On the right side, 0.1 is going to get distributed. 0.1 times X is 0.1X. And 0.1 times 100 is 10. And we're actually able to solve this equation already. We'll subtract 10. Get 20 equals 0.1x, and we divide by 0.1. 200 equals x. Now again, we need to go back and make sure we know what x represents. X represents the amount of the 0% or the pure water. All the other amounts are in milliliters, so that's in milliliters as well. And then we need to make sure we've answered the question. And the question here was how much pure water? So the 200 milliliters is our answer there. The next one I'm going to look at here is a much more simplified version of these questions. Actually, this would be number 5, not number 4. And what I'm going to ask is, if we mix um, 50 milliliters of 30% solution with 30 milliliters of 10% solution, what is the concentration of that resulting mix? So here we're mixing 30% and 10%. We don't know what the new concentration is. That's actually our variable here, X. For total amount, Well, we have 50 milliliters of the 30%, 30 milliliters of the 10%, which means the amount of the final solution is going to be 50 plus 30, or 80 milliliters. So next we want the amount of the solute here. 30% times 30% becomes 0.3 times the 50 milliliters. 10% becomes 0.1 times the 30 milliliters. And then we have X times the 80 milliliters. So now we'll combine what we can here. 0.3 times 50 is 15. 0.1 times 30 is 3. We will combine those to make 18. Then on the right side, X times 80 is just 80X. Now we're ready to solve the equation already. We're just going to divide by 80. 18 divided by 80 is 0.225. So that X represents the final concentration. 0.225 is 22.5%. Then we were asked to find that final concentration. So that is our solution, is 22.5%. So for number 6, we're going to ask how many milliliters 25% solution should be added to 200 milliliters of 10% solution to create I want to find 15% solution. I'm going to give you guys a few minutes to try this one in your notes. We'll go over it in just a couple minutes. So here we are mixing 25% solution and 10% solution to create a 15% solution. We have 200 milliliters of the 10%. We're wondering how much of the 25% should be mixed, so let that be X. So the amount of the 15% will be X plus 200. Then the amount of our solute for our equation, for 25%, it's 0.25 times the amount of X. For 10%, it's 0.1 times that amount of 200 equals 15% will be 0.15 times that amount of X plus 200. Now we can combine. 0.25 times X is just 0.25X. 0.1 times 200 is just 20. On the right side, 0.15 times X is just 0.15X. 0.15 times 200 is 30. Now we have an X on each side. We need to get rid of one. I'm going to subtract the 0.15X as the smaller one. So I have 0.1X plus 20 equals 30. Now I'll start to solve. I'll subtract 20. 0.1X equals 10. And I'll divide by 0.1. X equals 100. Now, there are some other types of mixing problems that we can do. I've stuck with those percent solution problems because that's what you guys needed for the coolant. But there are some other ones out there, like, for example, we're going to invest $10,000 in a combination of 5% and, oh, what do I do here? We'll go 5% and we'll do 9% accounts. How much should be invested in each if we want let's do $800 interest the first year. So what we are combining here is 5% and 9%. Now it doesn't tell us what percent we're getting, but it tells us we have 8% or $800 in interest. 800 divided by 10,000 is 0.08. So in other words, we're looking for 8% total interest. Our total amount here, we don't know how much of each. We just know that the total of $10,000 will be invested. So that goes over with our 8% total return. We'll let X be the larger percent, the 9%. So then the 5% is the total of 10,000 minus X. So in this case, now it's not a solute we're looking at, it's a total interest. So we've got still the same formula though. 5% becomes 0.05 times that amount of 10,000 minus X. 9% becomes 0.09 times that amount of X equals, I could do 0.08 times 10,000, but I know I want that amount to be 800, so I just put in the 800 there. If I put in 0.08 times 10,000, I'm just going to combine them to get 800 in the next step anyway. So now here we're going to distribute the 0.05. 0.05 times 10,000 is 500. And 0.05 times negative x is negative 0.05x. And then we have 0.09 times x is 0.09x. Now we can keep combining here on the left side. The 500 doesn't change, but negative 0.05x and positive 0.09x combines to make 0.04x equals 800. Now we're ready to solve. We'll subtract 500. 0.04x equals 300. And we divide by 0.04. X equals 300 divided by 0.04 is 7,500. So now once again, it's important that we go back and make sure we remember what X stands for. X here is the amount of the 9%. So that's $7,500 at 9%. But we also have to make sure we've answered the question. The question asks how much in each account. So we also need the 5%. So that'll be 10,000 minus 7,500 is 2,500 at the 5%. Another type of mixing problem is a labor mixing problem. So let's say that Sam can complete a job. Now, by a job, what we're going to do is it's a run of parts, a certain amount of parts. In, let's say 4 hours. Pat can complete the same job in 5 hours. So the question is, how long will it take if they work together? Assuming that no efficiency is lost with two people working together, that they can both continue to produce parts at the same rate as they work together. So this one's a little tougher. What we're mixing here is their labor and what they've accomplished. So we're going to change focus a little bit, and we're going to look at what they can do in 1 hour. Sam can do 1/4 of the job. Pat can do 1/5 of the job. So if we let X equal the number of hours that it takes to finish the job, Sam will do 1/4, which is 1/4 of the job times however many hours they work. Pat will do 1/5 of the job times however many hours they work. And they want the result to be one whole job. So just one. Now, we have looked at equations like this before, and there are two ways we've solved them. One way we could solve it is to combine 1/4 plus 1/5 times that, and that's still times x. Well, 1/4, if I do combine them that way, is 5/20, 1/5 is 4/20. So that would give us 9/20 x equals 1. And we would just solve that by dividing by 9/20. Gives us x equals 20 over 9, or 2.22222 hours. Now, the other way we looked at solving this was using that least common denominator. For 4 and 5, that least common denominator would be 20. So we could multiply the whole equation by 20. Well, 20 times 1/4 x would be 5x. And 20 times 1/5 x would be 4x. 20 times 1 would be 20. And you can probably see the similarity developing. 4x and 5x make 9x equals 20, and we divide by 9. So again, x equals 20 over 9, or 2.222. So just another type of mixing problem that you can run into. A third type of mixing problem is a cost mixing problem. I should say a fourth type of mixing problem. Let's say we have I'll be a little bit more specific. We'll call it material A costs $1.05 per pound. And B costs 85 cents per pound. To create 20 pounds at an average cost of 95 cents per pound, or sorry, 90 cents per pound. So I know how much of each is used. So we've got material A and material B here. Material A is the 1.05. Material B is the 85 cents. We want to combine those to come up to something that's 90 cents per pound. Our total amount, well, we know we're going to end up with 20 pounds of the final mixture. We'll let X be the $1.05 amount. So 20 minus X will be the amount of the 85 cent of material B. So again, we're going to look at the total here. We don't have to convert these into rates because they're not percents, they're just dollar amounts. So it's 1.05 times X plus 0.85 times 20 minus X will equal 0.9 times 20. And then we combine. So the 1.05x doesn't change. 0.85 times 20 is 17. 0.85 times negative x is a negative 0.85x. Well, we can still combine here. 1.05 and a negative 0.85 is 0.2x plus 17 equals, on the other side we have 0.9 times 20, which is 18. And now we'll go ahead and solve this, subtracting 17 from both sides. Gives us 0.2x equals 1, and we divide by 0.2. X equals 5. So again, we need to go back and make sure we know what x represents. X is 5. That's the amount of the $1.05. That's going to be 5 pounds. We also need to know the amount of material B, which will be 20 minus x, or 20 minus 5. That'll be 15 pounds. So 15 pounds of material B, 5 pounds of material A is what we need to create that mix. I think you guys have had enough for the day. Tomorrow, we will do a little bit of basic statistics, means, medians, modes. Thursday, we'll finish up if we need to do like a standard deviation and stuff like that. Won't be quizzes on it, but we will talk about some of the basics for control charts for statistical process control. We won't have enough time to get into it enough that I can quiz you on it, but like I said, I'll give you an idea of what those charts mean, where the numbers on those charts come from. So with that, you guys have a great day, and we will see you all tomorrow.